Dear students, welcome to the second part of this video. This part will be dealing with the third part of the question, that is C. I have already covered A and B in the first video. So let us look at the C part of the question. Derive a formula for rho G mean gram per cm cube as a function of P Newton per meter squared, and double check the results from B using the new formula. What this is saying is that derive this formula or rewrite this formula in such a way that the density will now be in gram per cm cube and the pressure will be in Newton per meter squared. So what we have to do here is to establish a relationship between pound mass per foot cube and gram per cm cube for density. Then for pressure, we are going to establish a relationship between pound force per inch square and Newton per meter square. So this is what we're gonna do. So by doing that, let's first of all, rewrite this expression. Okay, we have density. Let me take one here. So if you notice, we have density. Okay, our density is in pound mass feet cube. This is what we have, and if we do that, this must be also in pound mass feet cube. Okay, and exponential, we have 8.27 times 10 raised to the power minus 5. This is inch square pound force. Okay, then we have P, which is in pound force per inch square. This is what we have at present. So what are we gonna do? We want this to be in gram per cm cube. We want this also to be in gram per cm cube, and we want this this pound force P to be in Newton per meter square. So we need to establish that relationship. Please note, once we are able to convert this value from pound mass foot cube to gram per cm cube, and we are able to convert the pressure from pound force per square inch to Newton per meter square, then automatically the density will be the unit of the density will be gram per cm cube. Okay, so let's establish the relationship between all those different units. So for pound mass, we know that pound mass per foot cube. Okay, so we are just going to begin to do the conversion. Sorry. So we have 1 pound mass per foot cube. So let's find the relationship between mass and cube. So I can say 454 gram okay, 454 gram is equals to 1 per mass, 1 per mass, 1 per mass. Then I can also say 328 meter cube foot cube equals to 1 meter cube. Then 1 meter cube is equals to 10 raised to the power 6 centimeter cube. Okay, it depends on, I must say that it depends on the kind of conversion table that you're using. Okay, so you might be able to go in a way that is shorter than this, or a way that is longer than this, or same. You might go the same direction or the same route. So what do we have here? Now we have something cancels out, this cancels this, this cancels this, and what else can cancel? So pound mass cancels pound mass. So at the end of the day, you're gonna have 1.6 times 10 raised to the power minus 2 gram per cm cube. So now what is the meaning? The meaning is that the relationship between pound mass per foot cube is 1 pound mass per foot cube is equals to 1.6 times 10 raised to the power minus 2 gram per cm cube. So this is an expression that we need to, take note of. Let's do the second one. We know that 14.7 pound force per inch square is equals to 1.01325 times 10 raised to the power 5 Newton per meter square. So therefore, 1 pound mass, that if you divide both sides by 14.7, 1 pound force pound force per inch square is equals to 6.89 times 10 raised to the power 3 Newton Newton per meter square. So again, this is also an important relationship. Now we need to now rewrite this. Here you can see here it is in pound mass per foot cube, pound mass per foot cube. Now we need to write in gram per cm cube. So I will go now and rewrite that equation as, now I have gram per cm cube. Okay, and that will mean I'm going to multiply 1.6 times 10 raised to the power minus 2 times 70.5. So this will automatically convert this to cm cube. That is the meaning. Then exponential, what do I have? I have 8.27 times 10 raised to power minus 7. Okay, then over 6.89 times 10 raised to power 3. Okay, and that will make my P to be in Newton per meter square. Okay, so and this is what we have. So all these are within the exponential. So by the time we do the factorization and simplification, multiplication, and subdivision that we have all around, we're gonna have 1.128 exponential 1.2 1.2 1.2 times 10 raised to the power minus 8 P then is now in Newton per meter square. So this will be the final derived formula. So density in gram per cm cube, okay, is equals to that is equals to 1.128 exponential 1.2 times 10 raised to the power minus 8. Now given if we are given that P is equals to 9 times 10 raised to the power 6 Newton per meter square. What are we going to do? We're just going to substitute. So substituting P into this equation that we have derived, okay, we're going to have our density will be, just try to substitute 1.257 gram per cm cube, and this you can you can approximate this. It's clearly 1.26 gram per cm cube. And if you compare this answer here with the answer that we got in the B part, you will notice that they are both the same. So this is what the question has asked us to do. We should look at it and double check. The question says double check the results from B using the new formula. So we've been able to derive that formula, substitute for P, and confirm that the results of the two approaches are the same. So thank you.